One last piece of information that I need to add about this is that if I look at my acceleration, I have a constant positive acceleration of 2. I have a negative velocity, which means I'm moving in the negative direction backwards. That velocity is getting closer to 0, which means it is slowing down. So my position time graph represents an object moving in the negative direction and slowing down. If we were to look at future curves, a position time curve of an object that is moving in the forward direction and speeding up would look like this. The corresponding velocity time graph would look like that, and then the corresponding acceleration time graph would look like that. Speeding up in the forward direction, speeding up in the forward direction, this slope represents a positive acceleration. An object that is slowing down in the forward direction would have going up. It would go from fast to slow. The velocity time graph would be going from fast to slow, and the acceleration time graph would be negative. I'm going from fast to slow, slowing down in the forward direction, slowing down in the forward direction, negative acceleration, constant. The last scenario that we didn't discuss would be moving in the negative direction, but in this case speeding up in the negative direction. That would give me a velocity time graph that is in the negative region, but I would be speeding up in the negative direction, going away from the axis, and that would also give me a negative acceleration. If you notice, positive acceleration, the mouth of the curve opens up. Positive acceleration, the mouth of the curve opens up. Negative acceleration, it opens down. Negative acceleration, it opens down. My velocity time graph, I'm getting slower if I go towards the axis, and I'm going faster if I go away from the axis. Slower towards the axis, faster away from the axis, and my acceleration value corresponds to the slope of my velocity timeline.